we have solved the system of equations by graphing. For this problem, they're kind of holding your feet to the fire of, we're going to make you graph it. If they didn't have the graph right there, I could probably just find the solution and type it in the box. But let's go ahead and come out with the graph for this one. Now, because in 7.5, I want to find the intercepts, I'm going to work this one by finding the x and y intercepts. So y equals 3x minus 12. For the x-intercept, write that every time you find an x-intercept, and underneath that write y equals 0. That way, you can kind of put that in your long-term memory. I'll get 0 equals 3x minus 12. I need to solve this equation for x. I will do plus 12 on both sides. 12 equals 3x. That's 3 times x. The opposite of multiplication is division. And I have x equals 4. That gives me an ordered pair on the graph, x comma y pair. I'm going to write x comma y, and x is 4, y was 0, because that's what we plugged in for that. On this same equation, let's go for the y-intercept. So write y-intercept. Underneath that, the y-intercept, x is always 0. That's 3 times x right here. Y equals 3 times 0 minus 12. 3 times 0 is 0. 0 minus 12. Now I'm going to say something some of you might think is a little silly to say. If you've had trouble with adding and subtracting with positives and negatives, let's just type that in the calculator. 0 minus 12 is negative 12. So I end up with y equals negative 12. My x, y pair, x was 0, y is negative 12. On the graph, I'm going to go to the graph at this point, and you could go to the graph on the computer. On the graph, you would select the line tool, take the cursor, and go to the point 4, 0, and then that point it's going to secure the line down there. And you'll notice you can kind of spin that line anchored on that point. Well, you have to anchor it on one more point, which is 0, comma, negative 12 on the y-axis. Click on the computer, and that should secure that first line. I have to graph the second line. I'm going to go back to my paper where I'm showing the work. I'll write 3x minus 2y equals 6. For the x-intercept, I'll put y equal to 0. So negative 3x minus 2 times 0 equals 6. Negative 3x minus 0 equals 6, because 2 times 0 is 0. Negative 3x minus 0 is negative 3x. That's negative 3 times x. So I want to divide both sides by negative 3. and I'll get x equals -2. This gives me an ordered pair, -2 for x, 0 for y. On the same line, I need to find the y-intercept. For the y-intercept, x equals 0. Write that each time. We'll plug in 0 for x. -3 times 0 minus 2y equals 6. -3 times 0 is 0. 0 minus 2y equals 6. Now 0 minus 2y is -2y. So -2y equals 6. We're going to divide both sides by -2. And now I'll get y equals -3. So the pair, 0 for x, -3 for y. On my graph, select that line tool. Take the cursor to -2, 0, and then 0, -3. Now this is marked off by 2's, so -3 is right in the middle of -2 and -4, and connect the dots. I'm looking for the intersection point. When you're doing this with a graph, you're kind of living a little bit dangerous. I'm going to have to guess the point. As I look at this graph, I'm thinking, my guess, did y'all hear me say I'm thinking? I want to try to convey a little uncertainty there. I'm thinking it's 2, -6. I went 2 on x, down to -6 on y. So the answer, the solution set, type parentheses, 2, -6, close parentheses. I should double check that point. Now, they've given you the grid and you're actually graphing the lines on the computer grid. Your guess is probably going to be accurate if your lines are correct. I could check it by plugging this point in and seeing if it works in both equations. I'm going to kind of leave that one right there and get to some of the other ones you have questions about.